there. Welcome to my humble abode, peasants. Today we will be talking about four main things. The first, how an element is a pure substance represented by a chemical symbol. Then we will recognize that a limited number of many known elements comprise the largest portion of solid earth, living matter, oceans, and the atmosphere. After that, we will discuss the difference between elements and compounds on the most basic level. And finally, we will identify the formation of a new substance by using the evidence of a possible chemical change, such as production of a gas, change in temperature, production of a precipitate, or color change. We will give you tax practice, 2 open-ended challenge questions, and 1 experiment. Oh, hello there. I see you're back. I was just catching up on my reading. The first thing that we're going to talk about today is that an element is a pure substance represented by a chemical symbol. The periodic table is organized into groups and periods. The periods on the table go left to right. All the elements in the same period have the same number of electron shells. The groups go top to bottom. All the elements in the same group have the same number of valence electrons. All the elements have a specific atomic number. The atomic number shows how many protons are in an element. The symbol is a group of 1, 2, or even 3 letters that correspond to the name of the element. Occasionally, an element's name is in Latin, such as plumbum or lead, whose symbol is Pb. Bohr models of an atom are used to illustrate the atom. They show the number of protons and neutrons in the nucleus of an atom. They also illustrate the number of electrons and electron shells in an atom. For instance, in the Bohr model of hydrogen, you'd see 1 proton and 0 neutrons. You'd also see 1 electron shell which had 1 negatively charged electron. If 1 more electron was added, the hydrogen would have a full shell. Electron diagrams are illustrations that show how many valence electrons are in an element.
Oh, hello. While I was brushing up on my anatomy, I remembered that a common misconception is that you can create or destroy elements. That is in fact not true. For example, the Earth is made of about 28% silicon, 8% aluminum, 5% iron, 4% calcium, 3% sodium, 3% potassium, and 2% magnesium. Even if you take elements out of the Earth, they're only released into the atmosphere, not destroyed. In the atmosphere, we have about 78% nitrogen, 21% oxygen, and 1% argon. In the oceans, we have about 86% oxygen, 11% hydrogen, 2% chlorine, and 1% sodium. In humans, we have about 65% oxygen, 18% carbon, 10% hydrogen, 3% nitrogen, 2% calcium, and 1% phosphorus.
Here it is. Now we are going to identify the formation of a new substance by using evidence of a possible chemical change, such as a production of gas, a change in temperature, a production of a precipitate, or color change. If a new substance is created, then these might happen. Heat or light will be produced, volume might change, or a precipitate may be created. Creating a gas can occur from heating a liquid. To form a gas from a solid, first the solid has to reach its melting point to form a liquid. Then it has to reach its boiling point, and the liquid turns into a gas. Forming a precipitate is much like creating a gas. A solid has to reach its melting point to form a liquid, but the liquid cannot reach its boiling point, or else it will be a gas. A misconception is that if 2 ions combine, that it is a precipitate, but it is not. Having a change in temperature. Some things are hot and some are cold. It takes more than flipping a switch to change the temperature, though. A misconception is red is the hottest color, but really white is. The temperatures go from left to right on the hotness scale. Red is the coolest. The colors go red, orange, yellow, green, blue, indigo, violet, and then white, although white isn't really in it. A change in temperature is a physical change. Temperature is the perception of vibrational energy of the molecules in any substance. The faster they vibrate, the hotter the object is. While Earth rotates and revolves around the sun, sunlight hits either the northern or southern hemisphere. When the sun is hitting Earth, it creates it to be hot, or it is in summer. But where the sun is not hitting, it is cold, or in winter. A change in color. As you know, the color white is the hottest. Some examples of a change in color when something is hot is toast or meat. When bread is heated, it turns into toast. It changes the color and turns the bread brown after it is heated. So when something is heated, usually it turns color. Like in a toaster, the wire turns red.
Now we're going to talk about compounds and elements. A compound is made up of two or more types of elements that are chemically combined in a set ratio. That they cannot be broken down to two or more simpler substances by physical means, only by chemical means. Properties of compounds differ from those of their elements. For example, salt is made up of two compounds, chlorine, which is poisonous, and sodium, which reacts explosively with water. Compounds are pure substances, not mixtures. For example, table salt is not a compound because it is a mixture of sodium chloride, dextrose, and calcium silicate, and potassium iodine. But if these components are separated physically, each can be obtained in pure form and each meets all the criteria for compounds. Compounds are made of atoms, or two or more elements. For example, O2 and O3 are considered forms of the element oxygen and not compounds of oxygen. Compounds are chemically combined elements. Now we're going to learn about elements. An element is a pure substance that cannot be broken down into any simpler substances by chemical methods. In that light, an element is the simplest kind of matter. We're used to calling them elements, but we also call them chemical elements. And this is because they are the basis for all chemical combinations and chemical reactions.
Now we're going to tell you the vocabulary that you may not know. First, valence electrons. Valence electrons are the electrons on the outermost shell of an atom. Next, protons. A proton is a positively charged particle. Next, a neutron. A neutron is a neutral particle, so it has no negative or positive charge. An electron is a negatively charged particle.
A chemical change is a change that results in the change of the identity of a substance. A chemical reaction is the process in which one or more substances change to make one or more new substances.
A melting point is when a solid melts to become a liquid, and a boiling point is when a liquid changes form to become a gas.
Now before our lab, let's review some science safety.
Always tie your hair back.
Always wear closed-toe shoes, because if you're like my friend here and you drop a glass and it breaks, you can get seriously injured. Remember, no horseplay.
Don't eat or drink anything unless you're instructed by a teacher.
Always wear your goggles.
And make sure to report any problems. Now we're going to do our lab. You see, a physical change is when the matter changes in its appearance, but not in the chemical composition. That was a physical change.
By roasting this marshmallow, it is a chemical change because we are not just changing the appearance of the marshmallow, we are changing it chemically.
Always wear closed-toe shoes, because, like my friend here, if you wear open-toed shoes and you break a glass, it's gonna get really bloody. Okay. Always wear open-toed shoes. What?
Oh, hello. I didn't notice you there. Welcome to my humble abode, peasants. Today we will be talking about
It started.
We will recognize that a limited number of many known elements comprise the largest portion of solid Earth. Living in matter, such as production of a gas, change in temperature, a production of a precipitate, or a color change.